In this tutorial, you will learn how to write a lifecycle node with ROS2 and Python. I will first use a real-life example to explain what lifecycle nodes are, and then we will directly dive into the code. You will write your own node and trigger the lifecycle transitions from the command line. And just before we get started, note that I have a complete course with much more details where you also learn how to create a lifecycle node manager, how to add lifecycle nodes to launch files, write a C++ lifecycle node, etc., etc. You can find the link in the description below. And now let's get started. Before I explain what lifecycle nodes are and what different callbacks you need to implement in your code, let's actually understand why you need them and also when to use them. And let's start with an example that could be a real use case. Imagine you are writing a node to read images from a camera and to publish those images to a ROS topic. What you would do in the code is to create the ROS2 topic and other ROS communications. Then you would initialize the communication with the camera, maybe do some calibration. And then when everything is ready, you can enable the camera and start a ROS timer, for example, to publish the images on the topic at a given frequency. And all that would be started somewhere in the constructor of the class or just after you call the constructor. Nothing wrong with this, but now maybe you want to be able to easily enable or disable the camera and thus stop and start publishing on the topic. Also, you could want to connect or disconnect the camera, handle communication issues, change parameters for the camera or the topics, and this while the node is running. That's completely possible, and you can implement some custom logic in your code to do that. In the end, it will look like a kind of a state machine. And the good news is lifecycle nodes are actually made for this purpose. They contain a state machine that will allow you to easily separate your code for different parts of initialization or activation. Then you can easily switch between those states. And let's now see what is a lifecycle node with its state machine. As I explain the state machine, I will continue with this camera example so you have a better idea and a better understanding. So here is the official state machine that you can also find on the official documentation. I'm gonna come back to this later, but for now let's actually do a simplified state machine and let's build it step by step. So when you have a normal node, well, a normal node doesn't have different states, okay? You just start the node, so the constructor will be called. In the constructor, you initialize everything, and the node is kind of already active. Now, with a lifecycle node, you have different states that correspond to kind of different life cycles of the node. And the first state that we're gonna enter when we start the node is the unconfigured state. So in this state, the node will be, well, as you can see, unconfigured, which means that the communication with the hardware and also any ROS communication like topics, services, actions, etc. are not configured. Then we will have a transition between the unconfigured and the inactive state. And here to do this transition, we have this onConfigure callback. Okay, so that's going to be some function. So it's going to be a callback in your code that will be called so that you can actually configure your node. And what do we do in this onConfigure? For example, with the camera, well, here we would create the ROS2 topic. We might also initialize the hardware communication, okay, to make sure we can connect to the camera and maybe do the calibration, okay? So after we are done with this onConfigure, as you can see, the topic is created. So we don't publish on it, but it's created, and the hardware is ready. The hardware is configured. Now we are in the inactive state. So inactive means configured, but not active. We will need to trigger a second transition that's going to be onActivate. Okay, and what do we do in this transition? Well, we will enable the camera and maybe start the ROS timer. So that after the onActivate, the node will be in the active state. And while it is in this active state, well, the camera is enabled and configured, the publisher is ready, and the timer is ready so that we can start to publish the data from the camera. Okay, and here we don't need to worry about initializing hardware or anything else because that's already done in the previous state. And then the good thing about this state machine is that, let's say the node is in the active state, so publishing the images on the topic, you could call onDeactivate so that you deactivate the node, and here basically you would do the opposite of what you do in onActivate. So you would disable the camera, maybe stop the ROS timer. Okay, so the node goes back to the inactive state. It is still configured, but it's back to being inactive. And then from inactive, as you can see, you can go back to active by just calling onActivate again. Or you could decide to clean up, which means you go back to the unconfigured state. And when you clean up, you're gonna destroy the ROS2 communication. So here the ROS2 topic, you're gonna stop the hardware communication. So you can see you can go back from active to inactive and from inactive to unconfigured. And here you have the three main states of the lifecycle nodes. And there is one more state, is the finalized state. So basically when you want to stop the node, there is this onShutdown callback that's gonna be called, and you can call onShutdown from any other state. And here what you do, well, you're gonna basically deactivate and clean up everything so that the node can arrive in a finalized state, which means then, well, the node is not doing anything and we can just stop it. There is another state as well to handle errors, but we're gonna see that a bit later. For now, you can see that a lifecycle node will start in an unconfigured state, and then you have some transitions to go to inactive, to go to active, and also to shut down the node. And we are now going to write the code for a lifecycle node in Python. And so I'm not going to start from scratch, I'm going to start from a node that I've already written here. So that's a very basic node. Okay, so what I have done is I have created a ROS2 workspace, then I have created a Python package named Lifecycle Tutorial. Okay, so if you want to follow, you can do the same. And then I have created a file, lifecycletest.py. I have put this file as an executable file. And in this, I have just written a basic node. So the minimum code for a node. You can see from RCLPy node, I use the normal node object here, the normal node class, and I create a class here, my node. Okay, so the name of the node here is my node. In the main, what I do is I just initialize ROS2 communication, I start the node, I make it spin, and finally I shut down ROS2 communications. So this is the setup, nothing really complicated. And I'm starting from this very simple code so that it's going to be easier for you to adapt any other node with lifecycle nodes. And so what we are going to do here, we are going to first adapt this node to be actually a lifecycle node, and then to implement the transition callbacks. And after this, we will build the node, start the node, and then from the terminal, we will use the ROS2 lifecycle command line tool to trigger the different transitions and see when the callbacks are actually called. All right, and at the end of this tutorial, I'm also going to give you some additional information on when it is actually a good idea to use lifecycle nodes. Okay, let's get started with the code. The first thing is actually to use a lifecycle node instead of a node. So here we use the basic node class. Instead, we will need to import from RCLPy dot, and we have something called lifecycle. So lifecycle import lifecycle node. Okay, so I really encourage you to use the auto completion here, for example, with VS Code and the ROS extension, and we have lifecycle node. So then what I will do is simply, instead of inheriting from node, I will inherit from lifecycle node. Then the way to create the object here is the same. Okay, the way to make the node spin is the same. So nothing else to change. For now, we just need to inherit from lifecycle node instead of node. And I'm just gonna remove this import here. All right, so now we have a lifecycle node and we can do all of the transitions, but because we don't have any callback implementations, well, nothing's gonna happen. So let's come back to actually this image here. The node is gonna start in the unconfigured state. To go to inactive, we will go through the onConfigure callback. So let's actually do an onConfigure callback. We're going to add a new method in the class, and I'm gonna call it onConfigure. You can see I even have the auto completion, and if I press tab here, well, we have a bunch of stuff. So you can see that we're gonna receive a state. That's gonna be a lifecycle state. So it's gonna be the previous state before you get to the callback. So in this case, for example, if we are in unconfigured and we call onConfigure, we will know that the previous state was unconfigured. And then it's gonna return, so we need to return a transition callback return. So make sure that if you don't have the auto completion, you add those to the imports here. Okay, I'm just gonna remove this. Well, we could leave it, but just to have a bit less code. And I'm gonna do things a bit differently in the callback. So first, before we add any functionality, I'm just gonna put a log, self.get logger with info, and I'm just gonna put in on configure. Okay, so just to know that when we are in this callback, I'm gonna see this log. Okay, so that's gonna help us to introspect the node. And then I need to return what? I need to return a transition callback return. So that's what I have imported here. Dot, and then you can either return success or error or failure. We're gonna keep a success for this tutorial, okay, to keep things simple. So what we're saying here is we just print a log, we return success, which means that after onConfigure, then the node will be in the inactive state, okay? Then another callback we can implement now is onCleanup. So I'm gonna implement onCleanup if we want to go back from inactive to unconfigured. So I will do def onCleanup, and you can see we also have the auto completion here. I'm just gonna remove that. And also I'm not gonna use this. I'm just gonna put self.get logger info with in on cleanup. And then I also return the transition callback return success. All right, so as you can see, the minimum code to implement the callback is very easy. Next callback, let's go back here. Well, now that we have implemented those two, we can implement the onActivate and the onDeactivate. Okay, so onActivate to go from inactive to active, and onDeactivate to go back from active to inactive. So let's do those. Def onActivate. And you can see all the callbacks will have the same definition here, the same parameters and the same return. So we get the previous state, which is a lifecycle state, and we need to return a transition callback return. Now for onConfigure and onCleanup, you could see that I would return directly the transition callback return, but for onActivate, I'm gonna call the super, okay? And I'm gonna come back to this in just a few minutes. Here I'm gonna do self.get logger info in onActivate, okay, so we can easily introspect, and then I return super onActivate. So super, actually, we're going to call the onActivate from the Lifecycle Node class itself. And this is going to return a transition callback return, so that's no problem. And then I do the def onDeactivate, same, and I will put a log self.get logger info in deactivate. So on deactivate. Great. Now the last one we have is on shutdown. So from any other state we can call on shutdown to go to finalized. So I'm gonna also do def on shutdown. You can see same thing. And for this one, I'm gonna do it myself. I'm gonna do self.get logger info in on shutdown and return transition callback return dot success. There is one last callback that I didn't put here, is the on error, but I'm gonna skip it for now. And anyway, this callback is not so important and not working so well, so I'm gonna keep those 5 callbacks, okay, for now. So as you can see, when you have a lifecycle node, then you can implement, so basically you can override those callbacks. It's actually not mandatory, okay? You can skip some of them if you want. You could just decide to have the onActivate and onDeactivate, okay? In this case, you just remove the onConfigure, onCleanup, okay? It doesn't really matter. If you remove the implementation, the default implementation is gonna be called from the lifecycle node itself. All right, and here we haven't really done anything. We just added a log, okay? So we don't have any other functionality, just a log. Actually, I'm gonna add another log to here, self.get logger info in constructor. Okay, so we can know when we start the node, we are in the constructor, and then we are here, etc., etc. Now, before I try this code, I'm actually going to add a few things because, well, with this code, it's just gonna print in onConfigure when we transition with this callback, etc. So it's not really interesting. Here, I will add a simple publisher with a timer. So let's say we want to publish a number at a given frequency. So I'm going to use a publisher with a timer and to see how we can actually implement that inside the lifecycle node. And I'm going to use, so for the message, I'm going to use from example interfaces.msg import int 64. So you probably already know this one. Okay, just a basic integer number. We don't want to make things complicated here with the data type. Just use something simple. And then to create the publisher, usually what you would do is you would just do self.pub, for example, here is equal to self and then create publisher, okay? But we are not going to do this in a lifecycle node. So I will just create a pub that I will put to none here. So an undefined pub attribute. And then in onConfigure, so if you remember, we are going to configure the ROS2 topics and ROS2 communication in onConfigure. So we are going to create those. So in onConfigure, after this log and before we return, I will do self.pub is equal to self.create, and actually not create publisher. In a lifecycle node for Python, we have create lifecycle publisher. So I will create a lifecycle publisher. And then, well, the way to create a lifecycle publisher is the same as a normal publisher. So we put the type, so int 64, then we put the topic name, so it's gonna be number, and then we put a queue size, I'm gonna put 10, just like that. And here we have a lifecycle publisher. So note that when you just run the node here, it's gonna be in the unconfigured state, so the publisher will not exist. The publisher will only exist after you have called onConfigure. So when the node is in the inactive state, then you will be able to find the publisher. And what I will do is basically everything I do in onConfigure, I will do the opposite in onCleanup. Okay, as you can see here, you want to do the opposite. So what do I do in onCleanup? Self dot, and there is a method here, destroy lifecycle publisher with self dot pub. So I create it here, I destroy it here. As simple as that. Now, before I create the timer, I'm just gonna create a method here. I'm gonna call def publish number self. Just a method to publish the number using the publisher we have created here. So let's do message is int 64 message dot data is gonna be, let's just hard code and let's say we want to publish the number 5. Okay, it's not really a problem here. And then self dot pub dot publish with the message. And maybe we can also add a log here, self dot get logger dot info, let's say publish number. So we know when we publish the number. All right, now I'm gonna create a timer. So to create a timer, what you know so far is you do self dot timer like this, for example, is equal to self dot create timer, and then as soon as you create the timer, well, it's gonna start to call. For example, if we give this as a callback, it's gonna start to call this at the frequency that you give. So what I will do is I will do as I did for the publisher. I will just initialize the timer to undefined. So we actually don't create a timer in the init. I'm going to create a timer in onConfigure. So I will do self.timer is equal to self.create timer. I need to give a period in second, let's say 1 second, and then the callback is self.publish number. But then if you remember, well, with onConfigure, we just want to configure stuff and then it's still inactive. So we don't want to publish right away. We don't want to start the timer right away. So what I will do is I will just do self.timer.cancel. So I create it, but I cancel it right away. So it's not gonna call this callback. And then what I will do is here, we're gonna go here in inactive. when we go to onActivate, I will actually activate the timer. So in onActivate, here, I will do self.timer.reset. Okay, when you do reset, you restart the timer, and cancel, you stop it. So this way, the timer here is configured, but not working, and here it's activated. Okay, so we have a two-step process. And of course, everything I do in onConfigure, I kind of need to undo it in onCleanup. And everything I do in onActivate, I'm gonna undo it in onDeactivate. So let's do that. So onConfigure, we create the timer. In onCleanup, I'm just gonna destroy the timer. So self.destroy timer, self.timer. So after I destroy the timer, it's not gonna work anymore. And then in onDeactivate, well, if I just restart the timer here, I will just do self.timer. Not reset, but cancel. So I don't destroy the timer, I just cancel it. And as you can see, it's not so complicated. Everything you do in onConfigure, you try to undo it in onCleanup, and the same thing between activate and deactivate. In addition to that, well, with the onShutdown, you can see that we also want to, well, deactivate and clean up stuff. So here in onShutdown, well, we have a publisher and a timer. So basically we could just do the same thing as in onCleanup. So I'm gonna take those two lines here and say that we destroy the publisher and we destroy the timer. And that's gonna be pretty much it. Now, one thing to note also is, I'm gonna come back to this. Why do I call the super onActivate and super onDeactivate? Because you can see we have, it's not a normal publisher, it's a lifecycle publisher. So a lifecycle publisher is actually not going to publish. So even if you try to publish, even if you really publish stuff when you are still in the inactive state, the lifecycle publisher is not gonna work. So you will have nothing published on the topic, even if you use the publish method, okay? And when you do onActivate and you call the super onActivate, it's actually going to activate all of the lifecycle publishers that you have in the node. Okay, so that's important to call the super here. And in onDeactivate is going to deactivate the lifecycle publishers. Okay, so make sure that you use those two here in onActivate and deactivate. All right, and now let's try this. So I'm gonna go to my setup.py here, and I'm just gonna add an executable here. So let's say lifecycle test is equal to, so the package is lifecycle tutorial dot lifecycle test, that's the name of the file, and the function is the main. Let's go in the terminal, let's go to the workspace, and I'm just gonna do a callcon build. All right, so we have this normal warning here, but the package has been finished. Let's source. And now I can do ROS2 run lifecycle tutorial with lifecycle test. And as you can see, now we have in constructor. So I'm gonna open two new terminals here. So we just have in constructor, which is kind of normal because in the main, we create the node, we make the node spin. So you can see when we create the node, we're gonna run the code that's right here. But anything else here has not been triggered, okay? And if I do ROS2 node list, so I have my node. If I do ROS2 topic list, you can see I don't have, so I have some existing topics, but I don't have the number topic, all right? It's not here yet. It hasn't been created. So then I will use the ROS2 lifecycle command line tool, and you can do ROS2 lifecycle nodes. That's gonna list the nodes that are actually lifecycle nodes. So here you can also find my node. And then you have different keywords. So ROS2 lifecycle, if I do tab twice, you can see the different keywords. I'm gonna use the set keyword here. So set, and then I put my node, and then I will need to give a verb, and the verb is easy. Here you have on configure, on cleanup, activate, deactivate, shutdown. So you just take the configure here, cleanup, activate, deactivate, and shutdown. So I'm gonna put configure like this. I'm gonna press enter, and let's look at what's gonna happen. So transitioning successful. We went to the callback on configure, So we have run this code, and you can see we are in configure here. So in the terminal, you can see in on configure. Now if I do ROS2 topic list, you can see I have my number topic. So the topic is created. The timer is also created. We have cancelled it. And if I do ROS2 topic echo number, well, you can see nothing is being published for two reasons. First reason is because we have cancelled the timer. But even if we didn't cancel the timer, and even if we were publishing something, as the lifecycle node is not activated yet, then nothing is going to be published. Okay. Now what I will do is I will activate the node. So I will do activate. And let's look at what's going to happen. You can see in on activate. And then publish number every second, because now the timer has been reset here, which means we're going to run this every second. And also the publisher has been activated. So if I go back here, you can see we have published number and we have the data coming on the number topic. Now if I do deactivate, you can see we are in on deactivate. And we stop receiving data here from the topic. Okay, the topic is still here. We can still listen to it, but we stop receiving data. Okay, so what we have done so far is to go from here to here to here, and then back to inactive. When we are inactive, I can do a loop like this again. So I can activate. You can see in on activate, we get the data again, and then I can deactivate again. Okay, the node stays configured. And now I'm back to inactive again. From inactive, I can go back to unconfigure if I want. So just to show you, ROS2 topic list, the number topic is still here. But now if I do cleanup, okay, you can see on cleanup. And if I do ROS2 topic list, the number topic is gone because in on cleanup, we have actually destroyed the publisher. Okay, so that's how you can actually trigger the different transitions and the different callbacks. And note that you have to provide a correct transition. So for now, well, we are back to the unconfigured state. So the only transition you can call are configure and shutdown. If I try to call activate from here, so activate, it's not going to work. Okay, because you can see we can only call configure and shutdown. So actually it's called shutdown. And you can see in on shutdown. And now the thing is with shutdown, you can do, well, you are in finalized state and you cannot do anything else. Okay, so this is just for kind of introspection purposes. The only thing you can do right now is basically just kill the node. So Control C and we kill the node. All right, and you have successfully written your first lifecycle node with the different transitions. And you also know how to trigger the transitions with the ROS2 lifecycle command line tool. And just to finish here, I'm going to give you more information on actually when to use those lifecycle nodes and some best practices here. So one very common use case is if you are using some hardware. So that was the example I gave you at the beginning of this tutorial. So let's say you're initializing some hardware for a camera. Well, in onConfigure and onCleanup, you would initialize the communication with the hardware. Okay, so right here, you could configure the hardware. And also you would configure the ROS2 communication. If you have anything that would take time or anything that will allocate a lot of resources, then probably try to do it in onConfigure. Okay, so that's where you initialize the hardware. In onActivate, you're gonna just activate steps. So for example, if you are controlling a motor, then the communication with the motor is set up here. And then in onActivate, you will just activate the torque of the motor. Okay, so then you can control it. And also, this is going to activate the publisher, so the lifecycle publisher that you have created. Note that for anything else like a subscriber, a service server, an action server, there is not really a lifecycle version of those. Okay, those are gonna be normal subscribers, etc. It's just for lifecycle publishers. Okay, you have this specific thing about activating them in the onActivate. So here you configure the hardware. You also allocate the stuff that will take a lot of memory. And you set up ROS2 communication. In this phase here, on activate and deactivate, is going to activate the publishers, and you may also activate the hardware that you have previously initialized. So using Lifecycle Node is actually a good idea if you want to have more control on the order of initialization for your hardware. Okay, so you can easily separate the different parts of initialization. Another good point is if you want to synchronize several nodes, let's say you have 3 nodes that are controlling 3 pieces of hardware. Maybe you want to first initialize all the hardware and then to activate them at the same time. Well, you can have 3 lifecycle nodes, and then you're gonna call the onConfigure for each node and make sure that you wait until all the nodes are in the inactive state. And then once all the nodes are in the inactive state, you can just activate them all, and this is gonna be super quick. And then you can achieve a good synchronization between nodes. Then, well, to finish here, one thing you need to know is that lifecycle nodes are actually used a lot already in ROS2, specifically in stacks like navigation to or ROS2 control. Okay, lifecycle nodes are used everywhere. Alright, and that's the end of this tutorial on ROS2 lifecycle nodes. I hope you enjoyed it, and if you like the way I teach, then you will definitely love this complete 14-hour course in which you learn the most important ROS2 intermediate and advanced concepts. ROS2 actions, lifecycle nodes, executors, and components. The part on lifecycle nodes itself is almost 3 hours, so you will get much more details. For example, you will see how to create a lifecycle node in C++ and how to use a lifecycle node manager and launch files so you don't need to do the transitions by yourself on the terminal. Alright, thank you for watching, and I hope to see you in the course.